Okay, so I'm keep on recording the video about the lecture. So for the lecture part, still go through some definition ideas. And because as I received the email and then maybe you're still not yet working on the Raspberry Pi. So for this week, I still give you some extra time. If you couldn't get it, then you can still have extension to get your Raspberry Pi, because later for the week the first task you need to do, just like using the OpenSSL to generate the certificate, and then you need to do SSL to with the encrypt with the cert to log in. Okay, so here it will be the first step, like to connect to your Raspberry Pi with the security. Okay, and then the second for the next I will say the video for the next lab is about how can you control the GPIO, the pins. So always the easy will be giving the GUI to control on off, or how can using the Python script. So that's why for the smartphone security part of it, I will cover the Python a little bit. That will depends on based on your feedback, or like if you want to increase the amount of like the lab or the working. For the technical part, I can show you some example, then you can try to work on it. Then I can quickly go through all the lecture part. Okay, like part of it. So I would like to receive the feedback, and I wish I can set up some time. Because for the lecture part, actually you don't have to attend it as a time because I record it. I will want to like set up the time, maybe like together or maybe one or two. So because I know when you work on your Raspberry Pi, maybe you have some like technical issue or like how to connect and setting. So I can help you like in real time. I can help you to fix it. Okay. Then I will keep on just like recap about what we stopped by. So last time we talked about the IoT architecture, about the cloud, and some popular IoT cloud platform, including like AWS, Microsoft, and Google. So they are like, right now you can just use their service, like pay, and then you can, yeah, and subscribe, pay, then you can use it. And when you use it, then we need to think about how can we enhance the security, including the data encryption, some certain like access control or multi-factor authentications, and then secure the APIs. Because for the cloud computing, if we didn't take a cloud computing, building cloud computing, I will talk about how can we increase the security. Because the infrastructure, that means the service provider to make sure the infrastructure security. But for the application level will be should be controlled by us. So how can we make sure the security? Okay. And then we move on about the data management. So including those like management pipeline. One is about the data collection. So the IoT devices, they will gather the real-time data, and then the aggregation, how can we combine all the multi-devices data to a single stream, and then for analysis, and then where are we going to store, and then sometimes we have the notes like gateway, RP, the Raspberry Pi is like taking care this part. Okay, and then after we upload to the cloud, then how can we process the data and then do the analysis? This we need to do. And that's what we start by. Then next will be, we have some data security issue. Let's say, how can we ensure the data encryption at rest? So you see the term at rest, that means in database, like, and also in transition. That's what we always need to consider into situation for encryption. How can we make sure the data when we store in the database, no matter different type, but most of the time will be the NoSQL. Okay, because all the data, real-time data, we are storing in the NoSQL, and then in transit. So that means like, how can we make sure in communication? Based on the example, or when you learn cybersecurity, we already learn different type of like encryption method, asymmetric, symmetric method. So all these, and access control. So Only we mainly we need to create some authorized user or let the system have access to the sensitive data and then post to API. And also most of the time, because the the IoT data, we will let it open to public or like share to certain user or other third party. Then how can we make sure the access control, like all those like authorized user to access those sensitive data? Okay, and then the data integrity in the cybersecurity, we learn the CIA, confidential, and the integrity, and also the authorizing. Okay, and then this one, integrity, is like, do we have any mechanism to prevent the unauthorized data tampering? So this is what we need to consider. Okay. And also the integrity is really work on the maybe the sensor or the Raspberry Pi, like the one that devices we control. Are we sending the duplicate pieces, or like because certain mechanism, because we want to avoid loss of the data, then we try to sending the two duplicate. So based on timestamp, key, or maybe some order numbers. So we have different way to do it. Of course, we will try to do it. And then we have some protocols and different type. I talk about like the MQTT, COAP, HTTP, HTTPS, SMB, Bluetooth, or like LoRaWAN. So all this, we will go through about it. So why those protocols that matter in IoT? Because those protocols will mainly that will define how the devices and system being communicate. Okay, so we need to selecting appropriate protocol depends on the factors, like let's say the power consumption, maybe the data transfer rate and range, and some like reliabilities. So all this will be the consideration. How can we apply the protocol in different situation? Data size of these like then we can choose. If we in certain situation for the IoT stuff, we need to have low power consumption, then we need to choose some protocol. But if we want to have higher data transfer rate, we have lot of that. We need to switch another protocol. And the protocols we cover right here as an example, we do have 3 different layers. So the first one, for the networking, if we learn what the application layer would be level 7, the top. So MQTT. So this one will be on the application layer, HTTP, so software and transport layer protocol, including like TCP, UDP. Okay, so can we lose the data, or it's okay, just like streaming? Okay, we are okay to lose some package, or the link layer protocol. So it's right here, like actually a link. One of the I did in the past, like study would be the LoRaWAN. So I did will be using Arduino. If you know Arduino, I'm not using Raspberry, but we are specific. So based on the Arduino to change it to use for the create the LoRaWAN. So set up the gateway and then transmit it. So it comes really low power. And then that one would be monitoring the like maybe the open door gate and then the lift, maybe you call the elevator. So all this can use the LoRaWAN. Okay. And right now we will go like dive deeper about what these different protocols. MQTT is called message queuing telemeters transport. So it's a lightweight publishing or subscriber message protocol. So it's the ideal for the devices so limit resources. Okay. The devices, they can like publish the message to a topic or subscribe to a topic. Then they can receive a message. So this one is based on certain topics. So if we have specific, then we can like publish. That means we can send in the message, the data out to that, or subscribe. That means we can receive it. Okay. So usually it's two-way. And then we have the called the Booker-based architecture. So we have the central Booker facilities, and then we communicate with between the devices. So we have central as one, and then keep receiving or sending it to our the central Booker device. Okay, this is how it works. You need to know the features, like why. So it will be lightweight. That means it requires really minimal bandwidth and then low power usage. So if we do have a consideration about lower power consumption, and then with less like it, maybe in the architecture we don't want to like it occupy too much bandwidth, then we can choose MQTT in application layer. And it can provide maybe we call the reliable message delivery. So different level of QoS, the quality of service, and it's possible we can like higher scalability, that means support more devices in the large networks. Low power consumption, meaning bandwidth. That's what we can do. And in some situation, let's say if we need to provide us remote monitoring, some home automation, even the industry, some smart meter like have monitoring. So we have a central device, and then we can like receiving or probably send it back. So that's what we can do. We can use apply this one. Okay, just need to know certain examples, and how can we increase or the security things like for this one? First thing, okay, for the communication, because we always talk about two-way at rest and in transit. So in transition, so how can we encrypt with the TLS or SSL? And in the practice, like when we connect to Raspberry Pi, this we will always need to do. And then authentication. So only the authorized devices can connect. So we do not allow other third party or like anything to join this network. So how can we do? Then we'll ask like, how can we make sure those are authorized devices? So this is a question you can think about that. And also, how can we ask like the access control, like restrict like which devices can subscribe, publish data? So it's like coming together. Actually, authentication and authorization. So how can we restrict those devices? And when because when we're working on the smart things, like especially IoT, you are not thinking, okay, the Raspberry Pi, because we're using Raspberry Pi to demonstrate, to simulate. Okay, even in the industry, we're using Raspberry Pi, but we need to think about if in the company or manufacturer, how can we apply, it's like duplicate. We can clone all these devices, okay. Then if we are using this board like 1,000, maybe 1 million Raspberry Pi for using this purpose or like communicate to the central device, then how can we offline this? We cannot like just like setting one by one. Then how can we just like actually the next task like coming together to like how can we control GPI, or also one more thing, how can you make the image after you create everything? So in later, how can you make your create own image, then you can clone to your new device? Like you can publish anytime and then publish, and then maybe you need to send your MAC address and then keep it alive. That is a common project you need to do. How can monitor the live or like these devices, like where you should connect to, like connect to which API? Okay, and then next, the COAP. So it's a constraint application protocol. So this one is also is the lightweight protocol based on the REST. REST, if you know the API architecture, so it will be the constraint devices, and then also for the low power environment. Low power even looks similar. One is like low congestion. This one is like if you couldn't provide that much high, maybe like 1A or 5 volt, and if those are low environment, then how can we get? So it uses UTP instead of a TCP, so it's more efficient. It will be connectionless communication. It just keeps sending, and it's possible to lose the package. Is it allowed to do that? So it's like maybe some like resource discovery or some simple messaging. So here is a resource discovery. So maybe if we are looking for like connecting it, does it exist? Then we can use this one. Okay, and then this one can like optimize for the lower power, some low data rate network. Similar, And the message we're sending out pretty similar to the HTTP and just like even smaller. So for the low bandwidth scenario, and also it support multicast and all the devices they can send a message to multiple recipient at once. This one for the broadcast. If you want to like adapting certain new devices, then we maybe apply this one with the low power and then export to other devices. Okay, and you see maybe in the smart home, some environmental monitoring, also the industry. So all here some resource constraint setting. So in the smart home, if you want to focus or like adoption, I think you may be using this a lot. Okay, if you buy a purchase smart items, you need to connect to your Wi-Fi network or maybe through the Bluetooth. If you're using the app, once you press a search button, or they say, okay, when you press for 10 seconds, and then it will like allow for adoption, and then your app will comes up. So they can adapt automatically. So all this, then we can use this protocol. And what the security issue, and then what kind of things we need to consider. So here's we got the DTLS, datagram transport layer security. So we need to use it for the secure the communication over the UDP. Also, we can use some limited security mechanism, just similar to the HTTPS. So it can be like carefully configured. So that's what we try to use. And then next, about the HTTP and HTTPS in IoT. I think you should pretty familiar with that. Was HTTP is the protocol using for client server communication web page, and then we adding the SSL, so TLS, SSL to add the encryption to secure the transmission. And then also we try to preventing the address dropping or ensure the data integrity of an untrusted network. And the HTTP, we better talk about that. And this one is called a request response model. So mainly we're using like for the APIs and then some like web-based interactions, and try to add the secure the communication through the SSL TLS, the certificate, provide the encryption and authentication. So that's how it works. And you see a lot like the cloud platform, or sometimes the device, some like monitoring dashboard, some control devices for the API. So all these will build on the HTTPs. If you look at some device, they come with their own the IP address. Then once you type it, they go to port 80 or port 443 encrypted, then you can access to their cloud platform or the dashboard. That's how so that's why it always comes together. And pretty popular. I think you should be familiar with it. We just keep repeating using the SSL and TLS for encryption, and just like ensure the confidentiality and integrity. And also the API security, because when we work with the dashboard, like you say, the web-based, then we always need to maybe make sure the connect to the API. Then how can we ensure the security is same? Maybe the authorization mechanism, maybe some API keys, just like this. And I think this one is the in lower level, then it's a low power and same as low data rate wireless communication protocol. So maybe use that for the mass networking. If you know what's the mass, it will pairing with the network and then allowing device to relay the message to extend the coverage. So here's the key function, and then they use maybe for the smart home or some industrial automation applications. For the mesh network, it can isolate a router and also forward the data. I'm not sure how many they know more about the network. Then you need to, because smart things, we always are working with the networking. So we need to clarify, have some idea So if you know a mesh, if you I'm not sure the environment you're living. If you know your router, sometimes you cannot cover all of them. Then maybe you try to using a mesh to like extend your network. So that's what you're going to do. So kind of for router. And then when we decide this, we always like maybe ideal for some like battery powered devices, then we can provide low power consumption and maybe some like smart lighting, home automation. So you see the Philips hub. Okay, excuse me. Okay, some like security system that we are going to use. And for the security, we try to add in maybe the AS 128 encryption. So for the data confidentiality, and also we try to add the key management. So we try to make sure that devices joining some authentication, prevent unauthorized device to join the network. Just imagine the smart lighting. Okay, so the light we're putting on, then how can we like pair up joining? And we have the Bluetooth low energy. So compared with the regular Bluetooth, we try to optimize. So that one will be LE, so it will be the low power version. So it optimized for the short range communication, maybe under 100 meters. And we will maybe using for some personal area network, PAN. So before you see the LAN, then we have one more term, it's called the PAN. So this one is more like wearable fitness tracker health network. So this one is called the personal area network. Most easy direct your cell phone with your smartwatch. So that one we can call the personal area network. For those like we mainly design, they can running like on the small batteries and also like with the really short distance, typically maybe 10 to 100 meters. And or some may have monitors like nearby. And if in the I don't think they really using wireless. If you know in the second floor, like first floor in the ACP one, so there's some like have some monitor, but I think they connect to the cable, like physical connection. But for some like have monitoring, the Apple Watch or or other smartwatch wearables, home automation, some access tracking, so they can use the Bluetooth, more like personal area network. So that one will be even smaller if for the like if you buy the size, then would be pen would be lower than LAN. Okay, and then for the security consideration, I think you know more pretty familiar because I guess you use a lot. So what's the pairing algorithms? Okay, just works or like passkey. So how can we ensure the security device pairing? We can take an example from Apple. Apple, the Apple devices, actually they can pair so quick. If you use their, let's say you have their AirPods, okay, with the iPhone or like the Apple Watch with the iPhone, how can you can put nearby and then they can detect so quick? Especially the Bluetooth, when you take out the AirPod and put it on your ear, then how can they pair up directly? Then you can use immediately. Okay, then you don't have to wait. Then we can wait. And then also for the Bluetooth Low Energy BLE, then also it supports the AES encryption. And it's going to use. And here's the LoRa range. LoRa is a shorter representing the long range. It's called LoRa, and then wide area network. So it's called the LoRa range. Okay. If I can share, because this one actually is my previous company we did long time ago I working for. So it's a LoRa project. And also in my thesis, like I did some research like on how can I using the LoRa. So this and LoRa range is also the low power, long range wireless protocol. We design for some like we say the BLE would be like just personal network, and then for the lower range is like wide area network. So they can use like remote monitor, like application like agriculture, smart city, and logistics. So you see the cover range. So they can operate as a sub like gigahertz frequency bands, and also they can providing like coverage over some many kilometers. So it's really far away. And you can see the range, like let's say for 50 to 20 kilometers, and maybe some city, but city maybe because the buildings interference, then it will be like in really practical, the range will be lower. And then for the lower power, that means that it can run for years on a single battery. The advantage, because when you putting is a remotely, if you put the lower devices in somewhere really hard to access, you just leave it over there. Then you can go back maybe 2 years later, 3 years later. And for design, for this one, we call the low data rate. So it's for some small amount of data, maybe some sensors reading. If you, let's say you have a station on a mountain on the hill, and then you just returning those data. Because for my research, a little bit covering my research, like how can we apply maybe LoRaWAN using for vehicles, like quick, far away, and maybe for the situation, let's say in the state, okay. Because some, city from city, maybe 1 hour, 2 hours away, and then pretty far away. Then we can build less station and transmit. Use the less small amount of the data can showing the state current moment. Okay. And also actually for LoRaWAN, you can choose the gateway like to outfit. So that time my research is how can, based on the location and then the environment, and then to choose the best gateway. Okay. And as we use the LoRaWAN, of course, like in this one, I not require you to really like dive deep. If you're interested, you can look at it. But this one you just like in the lecture theory, then I just show you what's the LoRaWAN doing. So some for environmental monitoring smart city. So there's way or some agriculture sensor or like industrial IoT. So that's what we can use. And the encryption is like called the end-to-end encryption. So make sure that data integrity and privacy. Okay. Also the data authentication. So how can we use it, the unique key to authenticate devices on the network? So how can we pair edit? And why not? Okay, we talk about different architecture, then we move on, keep going about the data devices, communication security. Okay. Because suppose I have some question of time and cover lab, because I try to combine it together, then I can have a little bit lab, okay, and try to go through all this content quickly. Okay, so we have the device cloud communication security. So those like what the security, maybe including what the security advanced, maybe some data interceptions, maybe the man in the middle. It's always easy to happen if the devices in the cloud, so we can steal it. And device spoofing, so they can like impersonate the device to get unauthorized SSS, and then particularly the DOS overload the device or cloud infrastructure of the traffic, and then the data integrity. Okay, they will modify. So maybe sometimes many minute or transmission storage, the cloud promise the IoT system as well. And then it may affect, maybe lost the data integrity, privacy, so sensitive data may be exposed or altered, and also some like unauthorized control. So they can, attacker can manipulate the devices and also gain the access to the sensitive data information, all this. And just reminding, just like we talk about what's the best practice using for IoT, always the same. So TLS, SSL. So we try to securing the communication between devices, cloud, all this, and also pretty commonly we're using AES 128. Of course, we can increase high and 256. We can encrypting the store data and on the device in the cloud, but also trade off. Okay, for the access, we need to think about time, like high security, but it maybe takes more processing time. Then we need to think about that. And we keep on mentioning maybe like authentication, authorization. So maybe using the like 509 certificate, the authorized or like token, we can authenticating the devices or the role-based access control. This one pretty familiar, right? So we try to ensure just the user system, they have the permission they need. Always try to set the necessary and as least privilege for their role-based control. And try to always maintain the firmware, software update, regular update the devices, and the gateway to patch the known vulnerabilities. Okay. And also we need to implement secure over the air OTA update mechanism. If you maybe it's the first time here was the OTA, that means that your remote most of the vehicles, the vehicle system, so they maybe need to connect to internet, then they can update their firmware. So how can they do that? Fair trade or update, and then secure APIs and using all those like API keys to secure their access, and also the rate limiting or some other protection to prevent the abuse. I stopped too many access. And the access for the cloud to devices, just recapping like from the data transisting, preventing interception or tampering. So here, and then the 509 certificate, so they can use it to identify themselves. So we need to use it. Mutual TLS authentication, so ensure the both devices and server to like trust each other. And secure key management, we can either use the hardware security modules or TPMs, trusted platform modules. So you need to know the keywords. So how to like secure the stored like cryptographic keys, and also regular rotating the key to reduce the risk of exposure. So all these keys we sometimes we expire or we need to rotate, or we need to update the key. Okay, it may take time. And here's the extra lab because you may not have it. You will see all the lectures. I always try to add some lab or like trying to set up. If you're interested, like when I'm planning, so I try to add some like communication system, but I know maybe we are not able to cover all this. And I will show you some here's an example. So I didn't really go through, just like letting you know how can we set it up, and just like some security issue we can work on it. And that's what I'm not going to cover. And so far, just letting you know how can we understand the IoT architectures, all those components, their role. So just recapping, and then those like their protocols, and how can we, based on each protocol, how can we secure their communications? Okay, maybe especially we need to be careful device to cloud. Okay, this more because mainly from devices to devices or from the node, and they're not export to network, but from the net devices to the cloud is always easy. Like happy, those security will be much more like be careful because the man in the middle attack, but they some other devices, unauthorized devices to steal the information. Okay, so far for the lecture part will be stopped by right here, and we'll stop. And then for the next one, for the lab, I will record the lab. It will put a short lab will be about the set up the GPI control. That's what I say. Okay, thank you.